Hola, mi clase. So we are moving on, Module 6. Today is 6.1. We are identifying and representing functions. So our whole goal today is just to be able to identify and represent functions. So a function, and I should have switched these, so let's go down to relation. All right, a relation is just a set of any ordered pairs, right? Any ordered pairs. So 1, 1, 1, 2, 3, 5, okay? That's a relation. Any set of ordered pairs. Now, a function is a special kind of relation that assigns exactly one output to each input. So an input is a value that is put into a function. It's our x, right? So these ones, 1, 1, 3. And an output is the value that results from inputting, well, I might have to have two t's, but that's great, a value into a function. So it's our y's. So 1, 2, and 5. So for a function, there can only be one output for every input, okay? And I'll show you what that looks like a little bit more, all right? So remember, a function is just a special kind of relation. So to determine whether a relationship is a function, we look at our inputs and then our outputs, okay? So these are like our points. These are our x's, 1, 3, 7, and these are our y's, 2, 6, and 8. And what we've done is we've connected our x's with our y's. So 1 is with 2, that makes the point 1, comma 2. And since 3 is being pointed to 8, that's the point 3, 8. And then 7 is pointing to 6, so it's the point 7, 6. Now it says since each input value is paired with only one output value, this relationship or this relation is a function. So what we're looking for is here. We want to make sure that these x's only go to one y, because that's what it says, is that every output there's only one input, right? So the inputs are what we're kind of looking for, okay? So this is in fact a function because our inputs only have one output, okay? No x's repeat. So now we're going to look at this one. So we have the point 0, 1. We have the point 2, 4. And we have the point 2, 5. Now, since 2 is paired with more than one output, the output values, right, both 4 and 5, the relation is not a function, all right? And that's because the x's end up repeating. Right here, you can see that this input is paired with two outputs. And right here on our things, it says there's exactly one output for every input, only one output for the input. So if we look here, we have two outputs for this one input, and that's why it doesn't work. And so another way we could say it is that the x's repeat, okay? So we do not want the x's to repeat. So right here also shows me, here, let me use another color there. Right here shows me that this is not a function because that x's repeat. So when we're given a table, it's the same thing, right? These are my x's, these are my y's. I really care more about my x's. I want to make sure none of my x's have another y with them. So if I look, I've got the 0.57, 10, 6, 15, 15, 22, and 25, 15. If I look at my x's, I only have one of each, so we would call this a function, okay? Because I don't have this happening, or in a sense, I don't have this happening, right? So 1x for every y, so we're good. So now if I look here, I have, again, my x's and my y's. I have 1, 10, 5, 8, 4, 6, 1, 4, 7, 2. Uh-oh, I have two x's that repeat, okay? This would be like this, or like this, where I would have two of them. This can't happen. My 1 goes to a 10 and it goes to a 4. That doesn't work. We would just call this a relation, not a function. Okay, this is just a relation. It's just a set of ordered pairs. All right, so we've looked at a diagram. We've looked at a table. And then we're going to look at a graph. So the graph shows the relationship between the number of hours students spent studying for an exam and the exam grades. Is the relationship represented by a graph a function? So we, again, want to look mainly at our x's, and we want to see if there's 2 for every x. So if we look at 1, there's only 1 point. If I look at 2, I have 2 points right here. That means 2 outputs came out for 1 input. I can't have that. If I keep looking, you actually can see there's another one right here at 9. It happens twice. So this is not a function because those x's repeat. It's just a relation. Oops, I can't even spell the word relation correctly. There we go. Okay, so not a function, relation, because these x's right here have 2 y's, right? They've got 95 and 90 for number 9, and we've got the number 70 and 85 for number 2. That can't work. All right, so here's some more examples of tables. So I'm gonna have you probably, it'd be a best idea for you to pause. This time they want you to explain. Okay, so 7 and 8. I want you to determine if it's a function or not, and then I want you to tell me why or why not. Pause, please, and try it. All right, so this one you should have said that it is a function. All right, and because only one output for each input. So there's only one of these for each of these. These don't repeat. That's another way you could say it. These do not repeat. All right, I'm actually going to leave number 8 blank, and we'll go over in class and see how you did. We'll talk about what you guys did for explaining as well. So the main thing I want you to remember, the screen's going to change a little bit, is that functions, can't even spell, the x's cannot repeat. Okay, so that's the main thing. For functions, the x's cannot repeat. Okay, that's what we're looking for. All right, so here is the diagram form. Remember, these are your x's. This first one's always your x's or your inputs. My pen's not working. There we go. X, Y, X, Y. Tell me if this is a function or not. Tell me if this is a function or not, and explain. Do not forget to explain. Tell me why or why not. All right, until next time, adios.